Hi guys, welcome back to my channel. So today what we're going to be looking at is hopefully just a quick little video, and this is just about modeling data with technology. So the focus for today's lesson is really going to be on the use of technology rather than the mathematics. The other thing I wanted to talk to you guys today about was describing the fit of particular mathematical models to a set of data using Pearson's coefficient. So again, I'm going to show you how to do this using Excel, and then we're going to find a particular value, and that particular value is going to tell us whether or not a particular line or a particular function is going to fit that data well. So what we're going to do is we're going to just graph some equations, and I've actually done a sort of like a more quadratic type equation rather than a linear equation because I thought that would be a little bit more interesting. So what I've got here is I've got a photo. You may recognize this image. You may have seen this before. If you know where it's from, then comment down below. But for everybody else, what I've done is I've gone ahead and I've overlaid a grid over the top of this, and I've just picked, I think, like 10 points or something. Now, you don't have to pick 10 points. You could pick less than that, or you could pick more than that. Typically, as a minimum, I would recommend a minimum of, like, say, if you're going to do assignment, I would say a minimum of like maybe 10 points. I think that would be even an underestimate. I think most places at university level anyway would be expecting 30 or more points. So just be aware of that. But I've just picked a few points, and I've just put that in a table here. And so now what I'm going to do, I'm just going to take this table and I'm going to copy and paste it into an Excel file. And I just want to show you how simple it is to model this particular function using technology. So I'm going to just select my data. I'm going to go insert, and I'm going to go a dot plots or a scatter plot. So a scatter plot is just a relation that shows, it's just a graph that shows the relation between the x and the y variable. So this is my function here. Okay, so now what I'm going to do is I'm going to click on one of those data points, and I'm going to go add trend line. And for this particular equation, we can do this using a linear function. It's not exactly the most representative, right? But me just saying that, I don't think that's particularly scientific or particularly valid. So I'm actually going to show that to you mathematically as well. So what I'm going to do is I'm going to scroll down, and I'm going to tick both of those boxes there that show the trend line, and that also show the R squared value on the chart. And this R squared value, this is the value that we're going to use to decide whether or not this model is going to be a good fit for the data that we have. Now you guys can see that this R squared value is 0.039. Just for reference, a good R squared value, a perfect R squared value, is an R squared value of 1. When I was going through and I was doing my chemistry undergraduate degree, a good R squared value was anything higher than 0.95. In my biology subjects, the value was a lot lower. It was actually 0.85. And then for psychology subjects, that value, if it's a good fit, is going to be like around 0.6. So a good value just sort of depends on the branch of science or mathematics that you're going into. So for us, I would expect, you know what, let's be reasonable. Let's say above 0.85 is going to be a good fit for the model. Now, as you can see, this value here is nowhere close to that. It's 0.039. So what this is effectively saying is that maybe about 3% or 4% of the data is actually fit by this model. So we can change that now, and we can go through and we can click different options. So we can have this as an exponential function if we wanted to. We could have it as a logarithmic function, a polynomial function, or a power function. So what I'm actually going to do is I'm actually going to choose polynomial. So when I'm talking about polynomials, I'm talking about quadratics or cubics or quartics or things like that. So x to the power of 2, 3, 4, and so on. And so this number here, this order, this tells us the highest power of x. So in this case, x squared is the highest power of x. And if we have a look at this R squared value now, we can see that R squared value has actually gone up to 0.94. So a parabola is a much better fit for this model compared to that linear function that we were just having a look at. Okay, so that's how you would do that in Excel. So now what I want you to do is I want to show you how to use it in Desmos. So I'm just going to jump over to Desmos here. And in Desmos, when you get to this bit, you're going to add a calculator. So just going to add a table, and then you're just going to fill out that table, and then those points are going to come up. So I'm going to do that off screen. Okay, so I've just gone ahead and I've plotted those points in. Now this is just something as a little aside, but if you wanted to change the color, if you go into that settings, you click on the button, you can actually go through and change the color. So I'm just going to stick with black for my color. Oops, nearly deleted that. Woohoo! Okay, so the next thing that I did was I went back to that Excel file, and I've actually taken the equation from here and I've typed the equation into that Desmos calculator. And so if I press this button on and off, it's actually going to toggle that line on and off through Desmos. Okay, so what I actually want to do is I want to see the error term. So I'm going to go in and I'm going to put in a little 1 and a little 1 next to my X and a little 1 next to my Y. And I'm going to put this little tilde function. Now there it is, the little tilde function. Oh, it's coming up with an error. X may not be used. Oh, do you know why? Because I've also got to put the little 1 next to that X there. There we go. Okay. So the reason that you have to type in Y1, X1, X1 is because if you have a look at this table here, the letters at the top of this table are actually X1 and Y1. So you want to compare it specifically to this table, not just generally X and Y. And the other function that we got to use is this tilde function. So this is that little squiggly line that's next to the 1 button. And what this is doing is saying, okay, so this particular variable here, how well is that described by this function? So that's what that tilde symbol is saying in Desmos. And you can see here we've got an R² value of 0.946 as well. So typically there are a whole bunch of different ways that you could go about finding the model of an equation. We've done something similar with determining the can't talk this afternoon. We have done something similar where we've gone through and we've determined a linear function or a line of best fit based on a bunch of real life data. But what we've actually not been able to do is we've not been able to test how effective that line is actually fitting that data. And so this value here, this R² value, is the value that's telling us how well that does fit. So we could actually go through and we could work out a function by hand, and then we could actually type in that function by hand onto Desmos, and then Desmos can actually tell us how good that function is. Now, Excel is really good at finding functions, but you can't actually compare a function in Excel to work out what the different R² value of different formulas is going to be. So let's pretend, for example, that I'm really, I can't use Excel. I didn't know how to get this formula. How am I going to get this to work in Desmos? So what I can actually do is I can, instead of writing numbers, I can type in variables, and what Desmos will do is it will fill in those variables for me. So if I type in Y1 tilde AX², what was the next one? Plus BX plus C. And oh, again, I've got to put that in the little 1 next to all of my X's. Okay, and so then what it's done, it's actually gone in and it's told me the values for A, B, and C. So if I was to say, oh no, I put this point in wrong and I'm actually going to have to go back and fix this, and this value wasn't actually 1, it was 0.5. And so I've actually changed that now ever so slightly. And so you can see here, if I hit enter, excuse me, that's now changed those values of A, B, and C, and it's also changed my R² value a little bit because I've moved that point to make this function look a little bit more parabolic. So I hope that that's sort of explained for you how we find graphs using technology, so using Excel and using Desmos, and also how we're going to use an R² value to actually determine how well that model fits. All right. If you have any questions, just let me know. Otherwise, I will talk to you guys next time. Have a lovely day, and hopefully I will see you again soon.